So now let's talk a little bit about the whole data path. So here we see everything put together. We've got our memory, our register file, our ALUs, our branch logic, our sign extension, and the muxes we need to control everything. Let's talk a little about this, where things go and how they work, because you're going to need to think a lot about this design, particularly in the lab, but you need to understand this design so that when we talk about pipelining in the next lecture, you see how the two come together. So what do we have here? Well, we have our program counter, we have our instruction memory, we have our register file, and we have our data memory. What do all of these things have in common? So these are all memories. They all store state. So these are the state parts of our processor. What else have we talked about here? Well, we have our PC source, have our ALU source, ALU operation, memory write, memory read, register write, and this memory to register thing. What are all of these? These are all control signals. So how do we figure out these control signals? Well, we look at the instruction and we decode the instruction and we figure out what to set all of these values to for each instruction. So we talked a little bit about these, how the PC source, for example, is only used for branch instructions, or how the ALU operation is used to choose whether you do an add or an OR. Now let's take a look at this in some more detail. So what are the data sources in this processor design? That is, where can data come from? Well, the obvious one is the register file. So we've seen how we have these two output ports on the register file, and the data can come out of those and go into the ALU. Well, we can also get data from the instruction. Remember the immediate field. And to do that, we need to sign extend it. So we can take data from the register file or from the instruction. Where else can data come from? Well, we've got this data memory, so we can also get data from memory. And to do that, we need to output it from the memory and write it into the register file. So we have three places where we can get data from. Now, where can data go? Well, obviously data can go to the register file. And how do we get there? Well, we come out of the ALU and we go and write it into the register file. We can also put data into the data memory. And how do we do that? Well, we read it out of the register file and put it into the write data input on the memory. There's one other place where data can go in this design which isn't entirely obvious. It has to do with the data memory. And that's the data address. So we can take data and we can put it into the data address, and that allows us to control the address that we use when we're writing to the memory. All right, so let's take a look at an example here, the addi instruction. Where do we get data from and where do the results go? So the first input comes from the register file. First input always comes from the register file. There's no mux there, so we can't get it from anywhere else. The second input is an immediate value that comes from the instruction. So the second input is going to be sign extended and go through the mux there that's controlled by ALU's source. Now where does the output go? Well, addi writes back to the register file, so the output from that is going to go and get stored into the register file. So now that we've looked at this, we could write down what the logic equations are for some of these controls because we know some of the inputs. We know that for the addi input, those controls have to be set so that we get the right stuff for this instruction. So here's a question. What is PC source for addi? For this instruction, are we going to choose the output ALU result from the branch, or are we going to choose PC plus 4? Well, we're going to choose PC plus 4, and that's simply because addi is not a branch, so we always go on to the next instruction. So for this mux here, we're just going to take the PC plus 4.